You know, have you ever really stopped to think about what's going on under the hood of your computer? Like when you click your mouse or type something out, what's actually happening? Well, it all boils down to this one, single, incredibly fast process. And that's what we're going to dive into today. We're talking about the computer's true heartbeat, the instruction execution cycle.
So let's just kick things off with a pretty wild question. What if I told you there's one thing your computer does literally billions of times a second that makes everything else work? It sounds like magic, right? But it's not. It's this tiny, perfect, repetitive dance of logic that powers, well, everything. And the answer to that question? It's called the instruction execution cycle. That's the fancy name for it. It's really the basic operational process of any computer. Think of it like this. The processor is just reading a massive to-do list from memory and checking things off, one tiny little step at a time. Every single thing you do on your computer, it's just a really, really long list of these instructions.
Okay, that might still sound a little complicated, but trust me, at its core, it's actually a super simple and kind of elegant loop. We can break this whole thing down into a simple four-step dance.
And here are the steps. It's just four of them. Fetch, decode, execute, and store. That's it. The processor grabs an instruction, figures out what it's supposed to do, does it, and then saves the result. And then it just does that again and again and again, billions of times every second. Crazy, right?
All right, to really get a handle on this, let's use a little analogy. Let's imagine your computer's processor is like this super efficient, high-speed workshop. And the memory, that's its massive library full of blueprints. Let's go meet the crew that works inside. So here's our workshop. You can see the main processor right there, and it's all connected to the memory and everything else through what's called the system bus. Now, inside this workshop, we've got a bunch of different specialists, and each one has a very specific job to do in our little four-step dance. So let's meet them. Okay, first up, we have the program counter, or PC for short. This guy is our workshop's foreman. His one and only job is to point to the next blueprint that needs to be grabbed from the library. He's always one step ahead, always knows what's next on the to-do list. All right, so once that instruction is fetched, it gets slapped down onto the instruction register, the IR. This is basically the main workbench. It holds the current work order, the one single task that the whole workshop is focused on at this very moment. So you might be asking, how do we actually get the blueprints from the library over to the workshop? Well, that's where this gateway comes in, the MAR and the MDR. The Memory Address Register, or MAR, holds the address of the blueprint we need. And the Memory Data Register, or MDR, that's like the loading bay. It's where the actual blueprint, the instruction itself, shows up when it arrives from memory.
And last but definitely not least, meet the real star of the show, the ALU, the Arithmetic Logic Unit. This is our master craftsman. This is the part of the workshop that actually does the work. All the math, all the logical decisions, it all happens here. This is the real muscle of the operation.
Okay, so we've met the whole crew. Now, let's actually see them in action. We're going to follow one single, simple instruction and watch its entire journey through our processor workshop. So here's our work order for this example. Add R1, R0. Now, R1 and R0 are what we call registers. They're just tiny, super fast little storage spots right there inside the processor. So this command is pretty straightforward. It's telling the processor to take the number in R1, add it to the number in R0, and then store the final answer back in R0. Simple enough, right? Let's trace its path.
All right, so how does this little instruction get from the blueprint library into the workshop? It all starts with step 1, fetch. This is the moment the processor reaches out to memory and says, okay, give me the next thing on my list.
First things first. Our foreman, the program counter, knows the address in the library where our add instruction lives. So it copies that address over to the MAR, the Memory Address Register. It's basically telling the gateway, hey, I need you to go get the blueprint from this specific shelf.
Okay, with the address in the MAR, the control unit sends out a read signal. It's like officially submitting the library request form. Memory gets the request, finds the blueprint at that exact address, and zips it over to our loading bay, the MDR. And just like that, the instruction has officially crossed the bridge from memory and is now inside the processor.
And to wrap up the fetch cycle, that instruction moves from the loading bay, the MDR, right onto the main workbench, the instruction register, or IR. So now the work order is officially on the table. It's ready to be read, and it's ready to be acted upon.
Okay, work order is on the bench. Time for the next phase. Execute. This is where the magic happens. First, the control unit, think of it as the workshop's manager, takes a look at the blueprint in the IR. It decodes it, sees that it's an add command, and basically yells over to the master craftsman, "Hey, get ready, we've got an addition job coming up."
And now, our master craftsman, the ALU, gets to work. It reaches over, grabs the numbers that are currently stored in those little registers, R1 and R0, and it just does the math. It performs the addition exactly like the instruction told it to.
We're almost done. The result from that addition is immediately stored back into register R0, replacing whatever was in there before. But check this out. At the exact same time, our foreman, the program counter, is already being updated to point to the very next instruction in memory. I mean, the workshop is already getting ready for the next job before this one is even technically finished. Talk about efficiency.
So there you have it. We've just walked through the life of one single instruction. And it seems pretty small, right? Almost trivial. But let's zoom all the way out. Because this tiny repetitive loop, it's honestly one of the most important concepts in all of modern technology.
This number. This is why it all matters. That entire cycle we just watched, fetch, decode, execute, store, it doesn't just happen once. It happens billions of times, every single second. It's that mind-boggling speed and repetition that creates this smooth, seamless experience we all have with our devices.
And really, that's the big takeaway here. Everything, and I mean everything you do on a computer, no matter how complicated it feels, sending an email, editing a photo, playing a massive online game, it's all just built from billions and billions of these simple little instructions, all being executed one after the other in this exact same loop.
So that kind of leaves us with one final thought, right? We've seen how a single, basic blueprint, an instruction, is brought into the workshop and gets built. If this super simple, elegant process is the foundation for everything our computers can do right now, what are the next incredible blueprints we're going to ask them to build for us tomorrow?